let's look at a couple more. Continuing along, if we look at problem A in this next group, we've got the square root of negative 144. So you'd start this the same way we did the first couple of examples. We'd look at, well, what's the square root of 144? Well, we know that the square root of 144 is just 12. The problem is the negative on the inside of the root. Well, the negative on the inside of a square root comes out as an I. So our final answer for A is 12I. Let's look at B. In B, we have negative square root of negative 49. Let's see. I would start out with the easiest part, which is the square root of what's inside the 49. Well, we know that the square root of 49 is 7. We also know that the square root of the negative on the inside of the root comes out as an I. Okay, but there is also a negative on the outside of the root. The negative on the outside of the root will just get applied at the end and make sure that you end up with a negative answer. So our negative on the inside came out as an I. The negative on the outside actually meant you had a negative answer, which left us with a negative 7I. Let's look at problem C. In problem C, we have, we have the negative square root of 96. And so the question, just like any square root, is can it be reduced? Can you break down 96 into something that you can take the square root of? Well, the answer is yes. I can take the square root of, well, the 96 breaks down into 16 times 6. And I can take the square root of 16. It will come out as a 4. I can't take the square root of the 6, though, so that would stay inside of the root. Then the only other thing that can possibly come out is that negative that's inside of the square root. It will come out as an I. If it comes out as an I, it's not going to be in the root anymore. It's going to be out in front with that 4 we pulled out. So we get 4I square roots of 6 as our final answer. Let's take a look at D. In D, we have negative square root of 21. So we've got a negative inside of our square root that will come out as that negative will come out as an I. Now the question is, can I break down 21? The only way 21 can be broken down is into 7 times 3. But you can't take the square root of 7 and you can't take the square root of 3, so it doesn't help you. So I gotta leave that 21 inside of the square root. It can't be broken down into anything that helps. So only the I from the negative inside the root can come out. And so it becomes I square roots of 21. It looks funny, but that's the correct answer. So everything so far in this chapter is hinging upon the fact that the negative or a negative 1 inside of a negative or a negative 1 inside of a square root comes out as an I. Well, if you go a little bit further, you could actually get another property. You can square both sides of this equation, and what will happen here is we'll figure out that I squared equals, well, on the left-hand side, the square root and the squared will cancel out, leaving you with just negative 1. So that means whenever you see an I squared, you can replace it with just a negative 1. What does that actually mean, though? Well, let's look at an example off to the side here. Well, what that means is if I have, let's say, an 8I squared, I can replace the I squared here with a negative 1. So we'll leave the 8 alone and just swap that I squared for a negative 1. We'll put parentheses around it when we make the swap. Well, what does that mean I'm doing to the 8 and the negative 1? It just means I'm going to multiply, and that will turn this into a negative 8. What does that mean that the I squared did? It turned our positive 8 into a negative 8 because it turned into a negative 1. Let's try another one. So let's call that one A. Let's do another one. Let's look at B. What if you had, let's say, negative 6I squared? Let's do the same thing. The I squared would turn into a negative 1. So we'd have the negative 6 that was there. And then the I squared would turn into a negative 1. So then I'd have the negative 1 and the negative 6 side by side, which would multiply to become a positive 6. And that would be my final answer. So the I squared took the negative 6 and turned it into a positive 6. So kind of the punchline of this is you should never have a final answer with an I squared in it. We're always going to take these I squareds and turn them into negative 1s, and that will just switch the sign of whatever the constant was that was attached to the I squared. Now, this next one is you are set up in a little bit of what I would call a booby trap. So we have, in this next example, the square root of negative 4 times the square root of negative 9. I know that you're thinking a negative times a negative is a positive, but that is not what's going on here. Remember, these negatives inside of roots don't mean you have a negative number. They mean you have an imaginary number. So that's what we have to do first. We have to pull out these i's. So if we have a square root of negative 4, it turns into a 2i. And let's see, we've also got a square root of negative 9 here. That would turn into a 3i because the negatives are on the inside of the square root. We're multiplying, so what is 2i times 3i? Well, 2 times 3 is just the number 6. Well, the other part is if you're doing I times I, you do end up with 2 i's. That means you get an I squared. But what did we just say about I squared? I squared can be replaced with a negative 1. So we'll leave the 6 as is, and we'll replace that I squared with a negative 1. Well, then that gives me a 6 times a negative 1, which is a negative 6. So this is kind of the first time in math that you see two negatives, or what you think are negatives, turning into, well, staying a negative. But that is not what's happening. You have negatives inside of your roots, which actually mean that you have two imaginary numbers that are multiplied together, which turn into a negative real number.